So here's my research topic. It's about personalized abusive language detection using large language model and retrieval-augmented generation. And I'm the first author, Tsungcheng, and it's revised by Ernest and Sebastian. We all from Griffith University, Australia. So let's start with the research background. So abusive language detection system is a detection system that is able to determine whether the message is abusive or not. So this system can be used as a countermeasure on social media, try to identify and stop cyberbullying. So that is what the purpose of this system. And recent study has realized that individual subjectivity can play a big role in determining whether a message is abusive or not, such as people have different attitude, belief, or past experience may impact their understanding of a message. So that is why personalized detection is important. So this paper tried to evaluate the implication on large language model. So here is our solution, also our methodology as well. So to do personalized detection, we need two inputs. The first one will be message. The second one will be user's attribute. It can be their psychological features, their belief or attitude. So we need two inputs, message and user's attribute. In addition to that, we also need to retrieve some knowledge based on dataset that we will elaborate on later. So we're going to generate a set of roles. So we're going to combine message with user attribute and corresponding knowledge. We send all this together to a large language model. And hopefully this solution can improve large language models' effectiveness and also robustness. And in this experiment, we simplify this RAG to the embedding prompt for like a simulator for easier evaluation. So here is the dataset that we use for this research. That is Alpha, an abusive language detection dataset that includes psychological feature. That is a dataset we created a few years ago. So this dataset is comprised 3 features. The first one is message. The second one will be user's attribute that is measured by psychological measurement scale. The original one, it comprised 7 features, but now we only select 3 of them because of their significance in previous psychological and machine learning study. The last feature will be class. 1 means positive class, that means abusive. 0 means negative class, that means not abusive. So some of you might realize that why do we have a message? The same message, but different class label. That is because users may have different user attribute that will lead them to have different understanding to the same message. So that means the same message, because of their different attitude, they can have different consequence or class label. So this idea is based on 2 psychological understanding. The first one is people's emotional reaction to a message are co-created by the message and their attributes. So that means the class label shouldn't be determined only by message because that is co-created by message and the user's attribute. So that means one message can be related to more than one consequence or class label. So the second understanding will be that even though we know people may have different understanding to the same message, but in general, there's a rule that people with similar attributes can share a similar tendency to understand messages. So these are 2 understanding underpin this study. So this study, we generate 2 rule sets. The first one is based on association rule mining approach. I forgot to mention that. So this dataset comprise more than 100,000 of data lines. So I think that should be sufficient to generate these rules. So we generate 2 rule sets. The first one is based on association rule mining approach. We generate 9 rows in total, and 5 of them are related to the positive class that is harmful. These rows are determined by the confidence, lift, and support. So these are the rule sets for the harmful class for the associated role mining approach. The second rule set is based on the decision tree approach. So 13 of them were created by decision tree, and only 4 of them are related to the harmful class or the positive class. So these are conditions. They're determined by the probability and supports as well. So these are the results. So after that, we move to our evaluation phase. So our evaluation is based on ChatGPT 3.5 Turbo. In addition, we apply this attribute prompt technique to generate rows with ChatGPT. So that means that is the original rows look like this. But with this interactive technique, we try to ask ChatGPT, okay, can you please transfer this row to something you can understand? So this will be the results that we co-create with ChatGPT. So we transfer our rows from this format to this row format. After that, in terms of input, we select message and attributes. Then we'll ask ChatGPT to determine whether this message could be abusive or not based on not only message and user's attribute and also rows. The result should range from 1 to 0 to 1. 0 means not abusive, 1 means definitely abusive. So here is our first evaluation. It's about the effectiveness. So we randomly select 500 data points from our data set, and 36 of them were harmful class. And in terms of the results, DT, and that means the decision tree large language model. ARN means the association rule mining model. And the top one, that means that is out-of-box large language model. So according to the results, the large language model enhanced by the rules, it outperformed the out-of-box one, especially for the decision tree one. It achieved the highest accuracy, weighted F1 score, and also true positive rate. So that means how many true positive clause has been successfully identified, because that is the only benefit user can get from the abusive language detection system. So our second experiment is about the robustness of our solution. So we're going to evaluate whether our solution can withstand the contradictive scenario. So here is how we do it. So 100 joyful message will randomly select from this happy database and attach with the strongly attributes that strongly related to harmful clause. So joyful message with strongly harmful clause. Similarly, 100 prevent message were created by ChatGPT and they were attached with attributes that strongly related to not or the neutral clause. So you can see there are two contradicted samples out there. In terms of results for the out-of-box large language model, for joyful message, 100% not abusive. Prevent message, 100% abusive. That is perfect. And for the decision tree solutions, roughly 1 to 2% results that were flipped because of the attributes and the roles that we think this 1 to 2% is acceptable. But in terms of the association rule mining models, it ranged from 3 to 9% were flipped. So we realized that there may be a robustness issue in terms of association rule mining solution. So here is our conclusion. So we propose a solution improve large language model performance on making personalized prediction. Also, we compare the roles. We realize that extremely high self-done is always associated with harmful clause. Low rationality is generally associated with harm clause, and the correlation between irrationality is not clear. We also realize the limitation of our robustness experiment because that is conducted in this highly contradictive scenario. And we recognize that the true challenge will be test the real neutral message across diverse individuals' attribute. So that is about our work. Here are the citations and the dataset we use for this research. Thank you for your time. Any question is appreciated. Thank you.